Today on How It's Made. Plastic bags. Mass production. Solar panels. Inside knowledge for the self-sufficient. Plastic petrol containers. Essential when you're taking long journeys. And ice hockey sticks. Slap shots from the factory floor. But first, they've become the scourge of rubbish collectors the world over. Chances are, there's a growing pile of them somewhere in your house. Thankfully, at least now there's recycling which can purge both the conscience and the kitchen drawer. It's the humble plastic bag. Plastic bags are made simply from granules of linear polyethylene resin that will be melted. They combine the granules with other low-density resins in this mixer, where the combination is blended into a homogeneous material. Granules melt in the extruder, which heats them to a temperature of 240 degrees centigrade. A polythene film billows upwards in the form of a tube, several hundred meters long. When the plastic gradually cools down, rollers flatten out the tube. The tube is cut into two separate rolls. The polythene film is now easy to work with. A knife then cuts the film to the required width. The excess strip is salvaged in this tube. Several hundred meters of film are produced and rolled up. When the roll is full, the film is cut. A full roll weighs 158 kilos and can produce 35,000 bags. The next step is the printing of the bags. This alcohol-based ink circulates continuously to retain its viscosity. Impressions are made by inking rollers. Each colour has a separate run. Once printing is over, the plastic film is rolled up again. The roll is now full, and the cutting of bags can get started. This machine makes 150 per minute as a sealer bonds the edges of the bags together with heat. The wheel picks up the bags and puts them on two spindles that can hold 250 each. These bags are being fitted with a hermetic zipper. The zipper is made from a plastic pad, which inserts into a slot. Made in advance, the zipper is unrolled progressively. The zipper strip is cut and heat bonded to the bag at 180 degrees centigrade. A quick check that everything's functioning as it should. In another department, plastic bags with handles are created. Printed bags circulate on these rollers. A machine that seals the sides gives the bags the desired shape at the same time. Then another machine with a punch cuts the handle holes. Bags are heat sealed and cut at 150 degrees centigrade. And here, further designs are being formed. One end of the bag is heat sealed. This machine makes holes which let air out of the bag when it's being filled. This allows them to hold more. At this stage, a stamper cuts the handle holes. bags are cut to the required size, automatically sealing the other side of it. In just a single day, this relatively small factory can produce a staggering 1 million bags a day. Not so long ago, it was just the Greens and hippies calling for its introduction. Solar energy was a concept that seemed to either be the answer to all our dreams or just a flash in the pan. Well, the answer is somewhere in the middle. Welcome to the solar panel. Every house should have one. The concept of solar energy is simple. Panels soak up the sun's rays and transform it into electricity with mounted photovoltaic cells. The blue plate is made of crystalline silicon, and the grooves are the conductors. To make a solar panel, several of the modules have to be connected together, applied with a soldering flux. The solder wire is heated with an iron, and the modules are placed on a special support. Once the soldering is done, the modules are cleaned by ultrasound in water at 60 degrees centigrade. When dried and perfectly clean, they're ready to be modified. Now they can proceed with soldering the modules together. First, a flux is applied, which improves the quality of the soldering. With great dexterity, 4 groups are assembled, composing of 9 modules each. In this way, 36 modules are soldered and connected in series. Modules are assembled end-to-end and have to be handled with great care. Using a voltmeter, the voltage of each section is verified. At this stage, it's easy to remake a solder connection if there's a problem. If the voltage is adequate, suction grips attach themselves to the 9 rows of modules. In this way, there's no danger of contaminating the screens. The modules are placed in position. Then a metallic strip is inserted, which acts as a conductor, linking all the modules. A soldered connection finishes the job. Then a transparent sheet of layered glass is set. This serves as a rigid transparent form, which will support the modules. The rigidity of the form is enhanced by a laminate sheet. Finally, a sealing film is applied for protection. To laminate and stiffen the solar panel, it's placed in a hermetically sealed, heated oven with the air vacuumed out. The panel will cook at 80 degrees centigrade for 15 minutes. And once it exits the oven, all the components are bonded together. The panel is placed in a solar simulator for testing. Negative and positive contacts of the solar panel are connected to a voltmeter. The panel is inserted into the simulator, and a powerful lamp will illuminate it. The voltmeter is ready to make sure that the panels supply the electric current required. Different panels require different builds. Here, an amorphous silicon panel is being constructed. The panel is placed into a plastic frame and glued in place. Then the frame is screwed tight so that it won't move. The solar panel is put into a plastic frame and is now completed. fabrication of this panel will have required about 1 hour of work, and demand is sure to heighten as dual energy houses start to become a necessity. Coming up in how it's made: plastic petrol containers. Recycled plastics in a simple mould can save you a long walk to the petrol station. And ice hockey sticks, travelling at speeds of 100